Hello, my dear student. Today I am going to discuss about Edexcel IGCSE O-level physics, Unit 1, Chapter 1, Chapterwise question paper solution. Question number 1. The photograph shows a whale jumping out the surface of the sea. At the top of the jump, the whale velocity is 0 meter per second. The whale falls 2.2 meter from the top of the jump to the surface of the sea. Calculate the velocity of the whale when it hits the surface of the sea. Total marks for this question 4. Here initial velocity u 0 meter per second and height 2.2 meter. We have to find out the velocity, final velocity v, and here acceleration a equal to g equal to 10 meter per second square. So we have to find out the velocity. So we know v square equal to plus 2as, but for free falling object, because the whale fall freely, because the initial velocity of the whale is 0, so u square plus 2gh. So v square equal to u here 0 square, 2g here 10, and height 2.2. So v equal to root over 2 into 10 into 2.2. So answer will be after calculation root over 2 into 10 into 2.2 bracket close. So answer 6.63 meter per second. So 6.63 meter per second is the final velocity of the whale when it hits the surface of the seawater. So 6.63 meter per second. Answer 6.63 meter per second. Now a resultant force causes the whale to slow down when it hits the surface of the sea. Draw an arrow to show the resultant force. Remember, resultant force is the total effective force acting on the object. So it is a single, because it is slow, it falls downwards and it slows down, so resultant force will be upward. So this is the resultant force. Direction of the resultant force. Resultant force is upward. Next question, the resultant force acting on the whale is 18,000 Newton and mass of the wheel is 4100 kg. Calculate the acceleration of the wheel. We know resultant force equal to mass into acceleration. So acceleration equal to resultant force divided by mass. Here resultant force 18,000 divided by 4100. So calculate this one, 18,000 divided by 4100. So 4.39, that means 4.39 meter per second square, because the unit of acceleration is meter per second square. So 4.4 meter per second square. This is the acceleration. So here it is the mark is question. So final velocity would be 6.6 meter per second, and a vertical arrow drawn upward, and F equal to mh, so 4.4. So total question for total marks for this question. So total. Okay, now question number 2. A speed camera is positioned at the side of a road. The camera measures the speed of a vehicle on the road to determine whether the vehicle is traveling too fast. The camera takes two photographs of the vehicle 0.25 seconds apart. The photographs are used to measure the distance traveled by the vehicle during this time. State the formula linking average speed, distance moved, and time taken. Average speed equal to total distance moved divided by time taken. Now calculate the average speed. So average speed in the time between two photographs, the car traveled a distance 6.5 meter. Calculate the average speed of the car. So average speed equal to distance moved. Here distance moved 6.5 meter, and time 0.25 second. So after calculation, it is 6.5 divided 0.25 second. So 26 meter per second. 26 meter per second is the average speed. So answer 26. The speed limit of the road is 80 km per hour. Determine the whether car is exceeding the speed limit. We have to convert this 80 km per hour into meter per second. 80 km per hour means 80 km in 1 hour. So 80 km means 80,000 meter, and 1 hour means 60 to 60 second. So 80,000 divided by 3600. 80,000 divided 3600. So 22.5 0.2 meter per second. So the vehicle, so the car exceeds the speed limit. Speed limit. Now, question number B, the velocity time graph shows how explain how the graph shows the lorry has a constant acceleration. The velocity time shows how the velocity of a lorry changes with time. Explain how the graph shows that the lorry has a constant acceleration. Gradient of the velocity time graph, gradient or slope of the velocity time graph indicates that the lorry has a constant acceleration. Because the velocity time graph is has a constant gradient. State the formula linking acceleration change in velocity and time taken. We know acceleration equal to change in velocity divided by time taken. So A equal to V minus U by T. So that means gradient of the graph. So here final velocity is 24 and initial is 5. 24 minus 5 divided by, here time is 60 seconds. 60. Time is 60. So 24 minus 5 divide 60. Acceleration is 0.3166 per second square. So here 0.32 meter per second square is the acceleration. Yes. Now question number 3. Question number 3. A student does an investigation to how to show how the velocity of a toy car changes when the car rolls down a ramp onto a table and hits a wooden block. The graph shows how the velocity of the toy car changes with time. Calculate the distance traveled by the during first 4 seconds. First 4 seconds, here it is first 4 seconds. First 4 seconds. we have to calculate the area of the velocity time graph up to 0.4 second. So we know equal to distance equal to area under the velocity time graph. Velocity time graph. Area under the velocity time graph. So here area of the trapezium. Area of the trapezium. Trapezium. We know area of the trapezium here sum of the two parallel sides into height. So here A is this portion and B this portion. So here A 0.2 to 0.4, so here 0.2, and B is 0.4 and height is 4.25. So half 0.2 plus 0.4, 4.25. So calculate this one. 0.2 plus 0.4 into 4.25. 1.275. Distance here 1.275 meter. So acceleration, calculate the acceleration of the car between 0.4 to and 0.45 second. We know acceleration equals to v minus u, final velocity, minus initial velocity divided by time. That means change in velocity divided by time taken. After, so final velocity here 0 and velocity at 0.4 was 4.25 divided by time here 0.45 minus 0.40, so minus 4.25 divided by 0.05, so 4.25 divide 0.05, so 85 meter per second square acceleration, but it is deceleration. That means that's why value is negative. Value is negative. Then resultant force equal to mass into acceleration. So resultant force equal to mass here 0.13 into 85. So 0.13 into, so resultant force 110.5 Newton. Now question number C. Sorry, it is answer 11.05 Newton. So 11 Newton. A piece of soft material is used to the front of the toy car. Explain how this will affect the gradient of the velocity time graph after the car hits the block. So a piece of soft material. Remember, impact force equal to change in velocity divided by time. If there is a soft material, then time of collision increases. So impact force decreases, reduces the impact force. So mark scheme, time of collision increases. Increase the time of collision. Increase the time of collision. Time of collision. Then shallower the gradient on the graph. So acceleration will be smaller in magnitude.